Okay, welcome to another BACnet recording. This is for the sine and cosine rule and also area of a triangle using the formula half AB sine C. Okay, you don't need to worry about remembering the formulae because you will get given them just like this on the front of your exam paper. They're written out just like that for you. You may need to know that A over sine A equals B over sine B equals C over sine C can also be written as sine A over A equals sine B over B equals sine C over C. There's also a rearrangement of this one that you may want to use, and that might be worth learning as well. We'll come to that later on. And finally, area of a triangle, half AB sine C. The first thing you want to be doing when you're solving these triangles is looking just to make sure there's no more information you can add to the triangle that's been given to you. In this case, it's a very simple triangle and there's nothing more I can add. So I'm looking at this triangle, it's asking me to work out the size of angle marked X. I've got the side opposite, and I've also got this side and that side opposite. So I've got a pair of opposite sides and their angles. And that tells me I need to be using the sine rule. And the sine rule is A over sine A equals B over sine B equals C over sine C. Now I've not been given A, B, C on my triangle here, so I can just decide on them myself. So I'm going to say that is A. That means this side is little a. This could be B, and this side will be little b. I've also got C. Sorry about that. I've also got C and little c just here, and therefore I'm able now to solve the problem. I don't need the c and the little c. Okay, first of all, A over sine A equals B over sine B. Okay, I know what A is. It is 12. So 12 divided by sine X equals 10B divided by sine of 30. Sine A there was actually sine X. So sine X is on the bottom. I'm going to have to flip these two fractions the other way up to give me that sine X divided by 12 equals sine 30 over 10. Okay, let's just move this box here out of the way for the moment. Right, we will leave it there. I'll just go and work down here for you. Okay, so sine X is equal to, well, that 12 is dividing on this side, so it's got a times on this side. 12 times sine 30 divided by 10. I'm just going to enter that into my calculator now. So I'm going to do sine 30 divided by 10 times that by 12, and it comes out as 3/5. So sine X equals 3/5. I want to know what angle gives me 3/5, so I need to do inverse sine or shift sine of 3/5. Again, I'm on the calculator, so I'm pressing shift. Come on, calculator, turn on. Sorry. Shift sine bracket 3 over 5 close bracket equals 36.8. 36.869, and then some more. They've asked for the answer correct to one decimal place, so I need to chop the number off there. That means it would be 36.9 when I round it up. Okay, gone a bit all over the board there. Never mind, it's gone up there. In the exam you get a lot more room below here. I've just squashed this part B up to make it fit on. I'm now going to write that information on the triangle because I know it, 36.9. Okay, part B, calculate the area of the triangle. Well, area of a triangle, using the formula here, is area equals a half AB sine C. So A equals a half AB sine C. Sorry. Okay. Right. The trouble here I've got is that I don't know what angle C is. I could work out angle C, I suppose. What I do have is this side, which is side B, and that side is side A. So I know A and B, so they're the ones I'm going to have to use. That means I've got to find out what angle C is. Now that may seem a little bit complicated, and just before I do this I'm going to switch to a different colour pen, so you know now that we're doing the second bit of the question. Okay, well actually it's not that hard, is it? Because I've got 30 degrees there, 36.9 degrees there. Work out what that comes to. 66.9, 180 minus 66.9 will give you 113.1. So we know that's 113.1. So that's the angle there of that top angle that we have called, in this case, angle C. So now I can fill in my formula. A equals a half of A. Sorry, the area that should be, not angle A. Area equals a half A 12B. So 10 times 12 times the sine of 113.1. Okay, all I'm going to do, that's degrees by the way, all I'm going to do is type that in my calculator. So 0.5 times 10 times 12 times the sine of 113.1, and that comes out to be 55.189 centimetres squared, because it was in centimetres. They weren't correct, two significant figures, so I'm going to have to chop it off there. So it's going to be 55 centimetres squared. Okay, that's the question done. Let's look at the next question. Okay, again it's a triangle. Work out the length of BC. Give your answer correct, three significant figures. Just look and see if there's any more I can add to this triangle. There is nothing I can add. I've got two sides and the angle between. Now I like that question. Two sides and the angle between, that tells me I need to be using the cosine rule. Just need to learn that. Two sides and the angle between is the cosine rule. If you've got pairs of opposite sides, which we haven't in this case, but we had in the last question, if we go back there, we had pairs of sides and their opposite angles, we use the sine rule. But in this case, we've got two sides and the angle between, so we're going to use the cosine rule. And the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. I've just copied that, you might want to learn it. Okay, I'm going to label up my triangle just to be sure I've got the sides right. C, little c, b, little b, big A, so little a will be over here. There, done. That's lucky. The side I want is the side here, BC, that's side A. Sorted. Okay, so a squared is going to be equal to b squared, 6 squared, plus 4 squared, minus 2 times 6 times 4 times the cosine of angle A, which is 42. And now it's just a case of typing all of that into your calculator. So 6 squared plus 4 squared minus 2 times 6 times 4 times the cosine of 42 all comes to 16.3290. Now looking at that, seems absolutely massive, but don't forget that was a squared it was giving us. So a squared is that. If I want to find a, I'm going to have to just square root of that answer. So square root, all I'm going to do on my calculator, which you can't actually see there, is press the square root button and then the answer button, really quick, comes out to be 4.040921. However, they want the answer correct to three significant figures. So three significant figures from there. 1, 2, 3, chop it off there, 404. So A is equal to 4.04. And it was centimetres. Centimetres. Okay. Cosine rule. Use the cosine rule because I had two sides and the angle between. If this had been labelled differently, maybe C, B and A, I wouldn't be looking for A here. It would have been quite confusing. Now the best way I find to deal with that is just find the side I want, and if it's a cosine rule, I call that side A. Even if it's been labelled differently, I get my pens out and I just label it in my own way so it suits me with my formula. Right, here comes another question. In triangle PQR, now here's the information written down, but here's the information in a picture. I much prefer the pictures. First of all, calculate the area of triangle PQR. Well, we knew the formula for that from the last page. You get it on the exam paper. Area equals a half AB sine C. I just remembered that. Right, sine C. So this will have to be letter C because that's the only angle I've got. That'll make that side C. I'm then going to call this A and that B. There we go, A, B, C. Right, that's B, this will be little b. That's A, that will be little a. And now it's a case of putting the information into the formula. Area equals a half of 8.3 times 10.5 times the sine of 62 degrees. Okay, just put it into the calculator. 0.5 times 8.3 times 10.5 times the sine of 62 all comes to be 38.47. Sorry. Right, three significant figures again. 1, 2, 3. Now this time, that 7 would push that up to the 5, so it's 38.5. Area equals 38.5. Nearly forgot. Centimetres squared. Now, just as a little aside, it's not a right angle there. That height there, that's a sloping angle. But if it was a right angle, it would be a little bit less than 8. But let's just say it was near to 8. That there's 10.5. That's going to be a little bit longer than 10.5. Well, 8 times 10 would give me 40. Half of that, 8 times 10 would give me 80. Half of that is 40. So an area of 38 is looking about right for that triangle. So in the exam, I'll be happy with that. Right, next bit. Calculate the length of QR. Give your answer correct to three significant figures. Calculate the length of QR. So I want this length here. I've got the angle, and I've got two sides, and the angle is between the two sides. So I've got two sides and the angle between. That's the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. Now I label my triangle with that being a before, but now I need the cosine of that angle. So the best thing to do in the exam, get your pen, different colour pen if you like, or a highlighter or something, and just relabel it to suit you. So now this is going to be A. I'm going to stick with that one being B because it was. That means that one there will have to be C. Going back to my side, that's now little a. That is now B. That's still B. And this is little c. Okay, now I can answer my question. Here we go. A squared equals b squared. Now b is 10.5. 10.5 squared plus c squared is 8.3 squared minus 2 times 10.5 times 8.3 times by the cosine of 62 degrees. Okay, and now again, put it in the calculator. 10.5, sorry it's a bit boring for you. Whoops, made a mistake there. 10.5 squared plus 8.3 squared minus 2 times 10.5 times 8.3 times the cos of 62 comes out to be 97.3 on 1, 97.3, 111. That's what a squared is. Do the square root to find out what a is. So square root answer is 9.8645. 3. Okay, I want to correct the 3 significant figures. Here we go. 1, 2, 3. Cut it off. It's not going to change. It's a 4. So A equals 9.86. And don't forget it was in centimetres, so I must put my units of centimetres in. Okay. I chose this particular example because it was the angle, two sides and angle between, so it was a cosine rule, but twice we needed to reorder our triangle just by our own labelling to make sure that our formula fitted nicely with it. I hope you've understood how that's happened. Okay, this is the final question. And again, we've got the written information and then we've got the information here. Now this is a more complicated question. This was in the paper as towards the end of the paper. I think it was the penultimate question of the paper, so we're looking about A star for this. I'm not sure it's really that tricky if you're willing to take a problem-solving approach towards it. So, first of all, calculate the length of CD. That's what it's asking me. But before I even start, I'm going to have a really hard think about what information on this triangle here I can add before I start to solve my problem. So first of all, I've got a right angle there. That's a straight line. So this here must also be a right angle. So I'm just going to write 90 degrees there for later on. Now I've written that, I've suddenly realised that that's 50 and that's 90, 180, that's 40 short. So I can write 40 up there. Sorry, it looks more like 90, but it's actually 40. And just then I've realised as well, because that's 90, this one here must also be 40 degrees. So I've added some more information in that I wasn't given, and that may be crucial. Okay, I'm still trying to find C to D. Well, I've got 3 angles, all 3 angles of that triangle, but I've got no side. So that's really hard to get started with because there's no reference to what size that triangle is. We could make that twice the size it is and still the angles would be the same. That 19 there, I've only got one angle in this triangle on one side. That's not enough information. What have I got here? I've got a right angle. I've got 2 sides. Spotted it. Okay. If I draw this triangle out for you, let's draw it over here. What I've got there is a very simple right angle triangle. There we go. That there is 8 centimetres. That there is 3 centimetres. I've got a right angle triangle, Pythagoras. I've got 2 sides, I can find a third. So, 8 squared is 64. 3 squared is 9. So now I'm going to do 64, subtract the 9, equals 55. So this side will be the square root of 55. So I can now come over to my picture here, and I can write down that I know this side here is root 55. Okay. Now, let's look at this triangle again. If you want, you can use that one there, or you could actually just redraw it. And because I'm going on to do a second bit of this question now, I'm going to change colour pens so you can see the second stage of the workings again. I'm going to redraw it for you over here. Here is my triangle, and it's going to be this green triangle here. I'm going to copy out for you. I know that angle in there is 50 degrees. I know that angle there is 40 degrees. I know this one here is 90 degrees. I also now know that this side here is the square root of 55. And in the question I was being asked to find the length CD, C to D, which is the missing side. I'm trying to find this missing side here. I've got an angle and an opposite side. I've got an angle and an opposite side. So angles and opposite sides, that's the sine rule. So I can say that A over sine A is equal to B over sine of B. Okay, I'm now going to label my triangle, and I'm going to label it in a lighter colour green so you can see where we are. I want side A, so I'm going to call that side side A. That means that must be angle A. I've got B over sine B. I didn't worry about the C over sine C because I didn't need it. I just need this side here. So I'm going to have to call this side here B, which means that that there is angle B. Now I put my information into this formula. A is what I don't know, divided by the sine of A, which is 90, equals B, which is the square root of 55, divided by the sine of B, which is 50. Okay, now, You could be solving this using right angle trigonometry, and some of you may well want to do that because you've got a 90-degree triangle. Personally, I just like using the sine rule all the time. To have to learn another topic, I can just get away with doing the sine rule to do my right angle trig as well. But the sine of 90, if you type that in a calculator, you'll get 1. So you've effectively got a divided by 1 equals root 55 divided by the sine of 50 degrees. I'm sorry, I should have put that in brackets before to be strictly true. Now, anything divided by 1 is just itself. 20 divided by 1 is 20. 43 divided by 1 is 43. So a divided by 1 will just be a. So a is equal to root 55 divided by the sine of 50 degrees. I'm going to do that on my calculator now. Top of it is root 55 and the bottom of it is sine of 50. And that's given me 9.68115, and that's what a equaled. They've asked me to give it correct to 3 significant figures. So 1, 2, 3, 9.68, because that was a 1, there was a 1. So a equals 9.68, and it was in centimetres, I believe. Yep, centimetres. Okay, again, I've gone a bit wayward down here with this workings out. In the exam, we get given a lot more space than I had there, but I'm trying to squash all of the whole sheet of A4 paper onto one board here. Right, calculate the length of CE. Whoa. Okay, now, what I didn't do, which is silly of me, was I forgot to update my original picture here. I've worked out now what A is. I know this is 9.68. I've got to find C to E. I'm now switching to blue for this question. I've got this side, and this side here. Okay, let's draw that triangle out. I've got C to E, a triangle like that. I know, because what I did right at the very start, I worked out that angle there was 40. I know this here is 9.68, and I know this here is 19 centimetres. And I'm trying to find this distance x here. Well, two sides and the angle between. That is the good old cosine rule. So a squared equals b squared plus c squared minus 2bc cos a. Okay, well, I've got some c's, some e's. I did have a d down there originally as well, and an x. But the side I want is this side here. My formula is telling me that is side A, and I need the cos of that angle there. So I'm now going to label that accordingly. So A, that would be angle A. B and C don't really matter. Let's call that C, because I had a C there originally. And we'll call that now B, so that makes that little b. Okay, now put the formula in here. So A squared is going to be equal to B squared. Well, B squared is 9.68 plus C squared, 19. Sorry, I've got squared, 19 squared, minus 2, 9.68 times 19 cos of A, which is 40. Again, it's just a case of tapping it in the calculator. Do it quickly, sorry it's a bit boring for you. 9.68 squared plus 19 squared minus 2 times 9.68 times 19 times the cos of 40 all comes to 172. So A squared is 172.920,612. Okay, so A is going to be the square root of that. On my calculator, root answer comes to 13.149928. It's going to be centimetres. Hold on a minute, then we'll add the 3 sig fig. 1, 2, 3, I want to chop it off there. It doesn't round it up. So A is equal to 13.1 centimetres. Okay, job done. 13.1, looking at that, that was 9.8. It seems a bit long. Hopefully that's right. It's never exactly to scale. Okay, I'm going to leave it there. I hope that's been useful for you in terms of doing the sine rule and the cosine rule, and also the area of a triangle. And remember, just like we did here, for this question. You can use SOHCAHTOA trigonometry, but I honestly think you might be better off always using a combination of Pythagoras and then the sine rule. They're straightforward, and what's nice about that is you can carry on using the sine rule for all those questions that aren't right angle trigonometry, and actually you're not doing what in your head is a completely different topic. You're just using the sine rule with a 90-degree angle rather than a non-right angle triangle. That's the approach I would take. Hope that's been useful. Do watch some other videos. Thank you very much.